Good morning, IB. Welcome back to some more trig. Today I want to go through 8D, which is looking at the trig ratios and the unit circle and just seeing how they would connect together and how we can look at any sort of trig ratio in any part of the unit circle. Remember on the unit circle that any point around a unit circle, so point P, has coordinates cos theta, sin theta, so depending on the angle. So let's say we know that sin theta is 4/5, that means the y coordinate is at 4/5. So let's say here is our 4/5, which is the same as 0.8. So here's our 0.8 value, I'm going to write it up here. So whereabouts does the y coordinate equal 0.8 or 4/5? It could be this position, but it also could be that position. So there's two places where P could be, where sine is equal to 4/5. In other words, there are two angles that we could give as an answer, either that angle or this angle in here, that angle through there. So this one's the same as either pi minus theta or else theta. Anyway, we'll go into that in more detail in a moment. So if we wanted to find out the value of cos theta, we're not asked to find what theta is, we say what is cos theta, what's the ratio for cos theta, and what's the ratio for tan theta. So we know from when we were looking earlier that sine squared theta plus cos squared theta is equal to 1. That's the Pythagorean relationship within that unit circle. So we can now say that 4/5 squared is equal to cos squared plus cos squared theta equals 1. So we've got 16 over 25 plus cos squared theta equals 1. So cos squared theta equals 1 minus 16 over 25. Which means cos squared theta equals, what are you doing? 9 over 25. We take the square root of both sides. So cos theta is plus or minus, because we're taking the square root of 3 over 5. Alright, so we get two answers. Is that what we expected? Yes, it is, because we could have had this value, so that means down here, the x coordinate must be 3/5 if the y is 4/5, and this one here is at minus 3/5. So we can see there are two places where P could be, therefore two x coordinates, two y coordinates. So cos theta is equal to 3/5, that's the x coordinates. If we wanted tan theta, right, tan theta, do you remember what tan theta is? Tan theta, always think it's the gradient. So in other words, what's the slope of that line? And we do our relationship that tan theta is equal to sin theta over cos theta. So in other words, just need a bit more space down here, I might just work vertically. So if we know that, so tan theta, in the first case where we've got 4/5 is our sine, our y ratio. Let's take our positive 3 over 5. And if you've got a fraction like that, remember you can cancel because they're both divided by 5. So we get 4 over 3. So tan theta will either be 4 over 3, so that's positive. So that's your positive gradient. The other option is that tan theta is 4/5 over minus 3/5. So we get minus 4 over 3. So that's our negative slope. And that's our answer in quadrant 2. This is our quadrant 1 answer. So in quadrant 2, tan theta is negative. It has a negative slope. What I want to do is look at a different method. So in the first method, we use that relationship, cos squared plus sine squared equals 1. In here, what we can do is actually draw a triangle. If we have sine theta equals minus 3/4, I've taken a different value this time. And if it's minus 3/4, remember our sine theta is our y coordinate, which means it's either in quadrant 3 or 4. Alright, our ASTC. So sine is negative, it's in quadrant 3 or 4. But our domain, if we look at this now, in any trig question, always look at your domain. Tells us we're actually in the 3rd quadrant. Okay, so that gets rid of this one. We're in the 3rd quadrant. That means our point is somewhere down here, and the y coordinate is at minus 3/4. Okay, so here's our point down here. That's a P for point. Another way of doing this is actually consider a triangle. So because we've got something, we're going to use something that's bigger than the unit circle. So we could draw a triangle into here through our point. All right, back to our x-axis. So our theta here is representing our angle all the way around. And if it's sine, remember, our sine ratio is opposite over hypotenuse. So in other words, these sides here, it's negative because we're down there. The opposite side to the angle is here, and the hypotenuse is there. So in other words, we could be just thinking about a triangle. I'll draw it out here so it's a bit easier to see. Where we have sides 3, hypotenuse is 4, then we just need to see, well, what's our, this is our angle. If using our Pythagoras value, what is the value for our, in this case, it'd be like our x value. So 4 squared equals 3 squared plus x squared. So x squared equals 16 minus 9, which is 7. So x is equal to root 7. So now we can say that if we're after the cos theta and tan theta, cos theta in this relationship then is going to be the adjacent over the hypotenuse. So that's root 7 over 4. Using that, and because we know we're in that 3rd quadrant, it's going to be negative because we have a negative x value. All right, so over here, it's like considering this x value here. This x value here is negative because we're in the 3rd quadrant. Tan, is that going to be positive or negative? In the 3rd quadrant, it's positive because the slope of that line joining 0 and P, the origin of P, has a positive slope. So our tan theta is opposite over adjacent, so it's 3 over root 7, and it's positive. So 2 ways of doing it. We could have set up our sine squared plus cos squared equals 1, or you can consider a triangle that's in that 3rd quadrant where theta is the angle, the reference angle back to the x-axis. So 2 methods for doing that. I'll leave this one for us to do in class. In this case here, what we're doing is just considering those angles, and it's basically applying our ASTC. So So if we've got some angle in the first quadrant up to point P, so here's this angle. So this first relationship here is saying if I take pi minus theta, so that means we're now in that second quadrant over here, and this angle here is the same. So pi minus that, which is this angle here, is our pi minus theta. Then we can say that the sine of that angle, the sine of pi minus theta, is the same as sine of pi. And we can also see that because it's the y coordinate. The y is still both positive in both cases. Whereas if we take this next value here, next relationship, where we want cos of pi minus theta, because we're talking about the x coordinate, whatever we get for our x value for the first quadrant, take the negative of that to get the second quadrant answer. Because we now have a positive x value here and a negative x value there. Chords are lining up very nicely at the moment. All right, so that's just, it's basically applying the ASTC. So in this case, we've got quadrant 2, whereas down here in the third one, we're doing cos of 2 pi minus theta. That's talking about which quadrant? Quadrant 4. So we're looking at our point down here. So that comes back to there. There's our theta. So 2 pi minus theta is going to be all the way round to there. And we can see that the x coordinate, the cos theta, is the same as in the first quadrant. So they're both the same. The x values are the same. So the main thing here is when you're looking at your angles, think about your ASTC. Think about which quadrants where sine is your y coordinate, x is your cos theta is your x coordinate. So if we have tan theta equals 4, so that means the slope of the line is 4. If we look at our domain, we're between 0 and 2 pi. So here's our point. If it's got a positive gradient, it means it's sloping upwards with a gradient of 4. It could also mean the point was down here. So 2 possible answers for our point, both with the same positive gradient. So if we know that tan theta equals 4, theta equals tan to the minus 1 of 4. If you do that in your calculators, you come out with 1.33. I think inverse tan of 4. Don't forget we're in radians. 1.33 radians. So we're just going to work here in radians. So that gives us this angle. But because we're considering the whole circle, it could also be in the second quadrant, third quadrant at least, which means our theta could be that, or pi plus 1.33, which is, checking on your calculators, plus pi, we get 4.47. So 2 possible values for that answer. In the second one, so that was A. In D, cos theta is 0. So cos theta is, remember, your x coordinate is 0. So it's like having x is equal to 0. So what angle do we have at x coordinate equal to 0? If our point is up here, in other words, for theta equal to pi on 2, or 90 degrees if you want to call it degrees. Or it could have also been, as you're probably guessing, down here. That's your other possible point. So that 4 3 pi on 2, which is 270 degrees. So 2 possible answers for that. Sine theta equals 1 on 11. So then that's our y coordinate. Where is it positive? So it's 1 on 11, which means it's quite low. Here's our point. The same, so that's 1 on 11. It means it could have also been in the second quadrant. So sine theta is 1 on 11. Theta is inverse sine 1 on 11. Which equals, so I'm just going to work in radians, inverse sine 1 on 11, so that means our angle theta is 0.0910 to 3 significant figures, or in our second quadrant it could be pi minus 0.0910, which is equal to 3.05. That's it. All right, so 2 possible answers there. So make some notes on that, have a look at it, get any questions together, and then we'll go through these other ones in class. Thanks for listening. Bye for now.